Recording started, Selvakumar sir.
Okay, sir. Okay, students, we will start the session. So, before starting this today's topic, we will revise the topics discussed in previous session. So, in the previous session, I have discussed about magnitude comparator. Okay, so 1-bit magnitude comparator and 4-bit magnitude comparator. Okay, so what is meant by magnitude comparator? What is the purpose of this magnitude comparator? So, what we'll do with this magnitude comparator? So we will compare two input data and we will give a result as greater than, equal, less than. Okay, by comparing two input data, we will produce, or this magnitude comparator will produce two different outputs. Okay, that are greater, equal, then lesser. Okay, so then we have discussed parity generator and parity checker, right? Then we have discussed about how to implement a logic using the universal gates, NAND and NOR gates. Okay, so with the help of NAND and NOR gate, universal gates, how to discuss, how to implement combination logic or other logic functions. Okay, that are also we have discussed in the last session. Okay, so what is the purpose of this NAND and OR implementation? Okay, so we have a basic gates, AND gate, OR gate, NOT gate. Okay, but here we are focusing on implementation using NAND and OR gates. What is the reason? And also we are saying that these two gates are universal gates. What is that meaning? Universal gates means you can implement any function using these two gates alone, right? That's why we are saying that these two gates are universal gates. Then again, why these two gates are called as universal gates? What is the reason to select these two gates alone to implement logic functions? Okay, that is due to the advantage of these two gates compared to other basic gates. So if you are going for NAND NOR gates, you can implement these two gates alone using minimum number of transistors. Okay, if you are going for a minimum number of transistors, you can reduce the space and also you can increase the operating speed of the gates. Okay, so that are the advantages for our digital circuits. Okay, you can design a high speed circuits with a minimum amount of space required. Okay, so that's why we are going for NAND and OR gate implementation, right? So today we are going to discuss about memory devices, right? So nowadays in our day-to-day life we are using a lot of memory devices, so we are aware of these names, memory device, right? So what is meant by memory device? Can you give some example for this kind of memory devices? Any example for memory devices? You can type it in chat box. Memory card. Okay, so we are using SD card in the mobile phones, right? Then where you are seeing memory devices? Pen drive, yes. HDD, hardware drive, right? SSD, hard disk. Okay, so here we are using pen drive, that is standalone memory device. Then SD card in mobile phones. Okay, then like HDD, hardware disk driver. Okay, which is employed in desktop, laptops. Okay, so these are the memory devices. So what are the purpose of these memory devices? Why we are going for this kind of memory devices? What is the use of these memory devices? Storage purpose. Okay, Rizwan, very good, Rizwan. So we are using these kind of memory devices for storing some information, that is data. Okay, so here these devices are digital systems. Okay, so what kind of data can be stored within this memory devices? Obviously, zeros and ones, right? Logic 1, logic 0. So we are storing the data, okay, in terms of logics. It may be logic 1 or logic 0, zeros and ones, right? So here we are going to discuss, or we are going to give introduction about different memory devices available, right? So as you said, so it is a um, storage element. Okay, so these memory devices consist of lot of storage cells. Okay, for example, um, if I'm having a memory device like this, okay, so consider this is a memory. So in this memory, we are having lot of cells. Okay, we have lot of storage cells to store data. Okay, so this each block stores 1 bit data. Okay, if this cell stores an 1 bit data, then this particular cell is called as storage cell. Okay, this cell can store 1 bit data. So collection of these blocks or these kind of cells, you can form a large quantity of memory, right? So like that, we are fabricating the large amount of, or that means large capacity of memory devices. Okay, so we are saying that nowadays 1 gigabyte, 1 terabyte, okay, that memory devices are possible by combining 1 bit storage cells, right? So memory device is a collection of storage cells which are used to store and retrieve the information when required. Okay, so this is your memory device. In this, we are having lot of single bit storage cells, right? Then the information being stored in this memory is referred as data. Okay, that means in each cells, storage cells, we are storing zeros and ones, right? That zeros and ones is nothing but the data or information, right? Then where we are storing that particular information. For example, I'm selecting this cell. Okay, I'm selecting this particular cell. Okay, I'm going to store logic 1 in this particular cell. Okay, how to store that logic 1 in that particular cell? For example, name it as cell number 2. This is 1, this is 2. Okay, I need to store my logic 1 in cell 2. Okay, so how to pick that particular cell? For that, we have to use the address lines. Okay, so this address line, okay, says the data where it should be stored in the memory device. Okay, so the location of data within the storage cell is called as address, right? So with the help of this address, you can select a particular storage cell in a memory device, okay, which helps to store the data where you want, right? So data is nothing but the information which is going to be stored in the memory device. Okay, address is nothing but this address says the location of the data, okay, where it should be stored. Then, so we have two different types of memory devices. Okay, one is volatile, another one is non-volatile. So what is volatile memory? So volatile memory is a storage space that maintains its data while the device is powered on. Okay, when the power is on, volatile memory can keep the data. Okay, if the power is shut off, okay, power is turned off, what will happen? The stored information will be lost, right? So volatile memory can maintain a data when it is powered on. When the power is cut off, then data will be lost. Okay, so you can also say that it is a temporary memory. Okay, so this kind of memory can only store the data when the device is powered on. Okay, when the power is cut off, the data will be lost. So these kind of memories are called as volatile memories. Okay, the other category. So example for this volatile memory is RAM, random access memory. Okay, this is example for volatile memory. Then the second category of memory is non-volatile memory. Okay, so non-volatile memory can keep the data even though the power is shut off. Okay, so non-volatile memory can maintain a data. Okay, it can hold and save the data even though the power is turned off. Okay, volatile memory can retain the data even though the power is turned off. Okay, so example for this kind of non-volatile is nothing but ROM, read only memory. Read only memory. Okay, so RAM is the example for volatile memory, ROM is the example for non-volatile memory. Okay, volatile memory means it can store or it can hold the data when it is powered on. Okay, once the power is turned off, then RAM can, excuse me. Sorry for the interruption. Okay, so RAM can maintain a data when it is powered on. If the power is shut off, then data stored in that memory can be lost. Okay, this kind of memory is called as volatile memory. Then the ROM is the non-volatile memory. So ROM, read-only memory, can store or hold the data even though the power is turned off, right? So this is the flow chart representation of types of memory. Okay, so we have two different memories. One is volatile memory, another one is non-volatile memory. So example for volatile memory is RAM. This is the example for non-volatile memory. So ROM is the non-volatile memory. Okay, so we'll discuss about RAM, random access memory. Okay, random access. So what is that meaning? Random access. Access means what? What is meant by access? So it is a memory. So with this memory, we are going to do some access, right? So what is meant by access? So we are dealing with memory, right? What is that meaning? Controlling. Yes. What kind of control? ஒரு எஸ்டி கார்டு இருக்கு அப்படின்னா மொபைல் ஃபோனில் நம்ம எஸ்டி கார்டு வச்சிருக்கோம். ஸோ அந்த எஸ்டி கார்டில் நம்ம என்ன பண்ணுவோம்? ஃபோட்டோஸ் இல்லை வீடியோஸ் இல்லை சம் மெசேஜ் இல்லை ஒரு டாக்குமெண்ட்டை வந்து சேவ் பண்ணுவோம். ஸோ சேவ் பண்ணுற மீனிங் என்னப்போ? we are saving some content inside the memory. What is that meaning? We are saving some content, right? We are storing some content. Okay, it may be image or video or document. What is that meaning? We are writing into the memory. Okay, the storing into the memory is nothing but writing into the memory. Okay, then if you want to see some data, okay, if you want to see some video or image from that particular memory, okay, SD card la irundha na or some image file o illa video file o illa or pdf illa or word file o na vandu enna pannom view pannom. adukku enna pannuvom? நம்ம எந்த இடத்துல ஸ்டோர் பண்ணியிருக்கோம். ஓகே, ஸோ வேர் வி ஆர் ஸ்டோர் த பர்டிகுலர் கண்டென்ட். ஓகே, அந்த பர்டிகுலர் ஃபோல்டரை ஓப்பன் பண்ணி வியூ பண்ணுவோம். ஓகே, ஸோ வியூயிங் தி கண்டென்ட் இஸ் நத்திங் பட் ரீடிங் தி டேட்டா ஃப்ரம் த மெமரி. ஓகே, ஸோ ஹியர் த அக்சஸ் மீன்ஸ் the writing and reading operation with the memory device. Okay, so with this memory device, we will do write and read operation. Okay, that kind of operation is nothing but, that kind of approach is nothing but access with memory. Okay, then random access. Okay, so inside the memory, randomly you can write the data or read the data. Okay, based on the location we are representing. Okay, so randomly you can read the data and write the data into memory. Okay, so that's why the name random access memory. Right? So RAM is used to store and retrieve the binary information from desired random location. Okay, so you can randomly store the data and randomly read the data. Right? So RAM allows data to be accessed. Here accessing means reading and writing operation. Right? So it is a read-write memory. It is a read-write memory means you can do read operation as well as write operation. You can store the data and also read the data from the memory. Okay, so it is an example for volatile memory. So RAM is called as volatile memory. Right? So volatile memory, that means you can do both read operation and write operation. Right? So what are the signals this kind of memory should have? Okay, so this kind of memory, RAM has input lines, output lines, address selection lines. Okay, so input lines defines the data should be stored inside the memory. Output lines gives the data retrieved from the memory. Okay, the address selection line, which says where to store or from where to read the data. Okay, that is represented in address lines. Okay, then the fourth signal is control lines. This control line says which kind of do with memory. Either if you want to read the data or write the data. Okay, so to select this kind of operation, we will use control lines. Okay, so this is the block diagram representation of memory device. Right? So here we are having m number of input lines. Okay, so data input is m. Right? Here m number of data inputs are applied to the memory. Right? Similarly, m number of data is taken from the memory. Okay, so m input is given to the memory. Similarly, m output data is taken from the memory. Along with this two input and output lines, we have address line. That is n number of address lines. Okay, so this here the n represents the number of locations. Okay, based on this letter n, okay, you can define the size or capacity of the memory. Then these two lines, read and write, these two lines are control lines. Okay, so this is where address line, this is where control line, this is your input line, then here is the output line. Right? So this is where a block of memory unit. With this memory unit, we have different signal interfaces. Okay, so this m data input lines, m data output lines, n number of address selection lines, then 2 number of control lines. Okay, so within this block, you can see some notation 2 power n into m. What is that meaning? 2 power n into m. Actually, this representation shows the size of or capacity of the memory unit. Okay, so the capacity of the memory unit is decided by the letter n and m. N represents number of address lines, m represents the data, the length of the data stored inside the memory. So based on these two information, we are defining the size of or capacity of the memory unit. Right? So for example, I'm having a input data which is 8-bit. Okay, so similarly you will get output data as 8-bit. Right? Then here I'm defining the address lines which is equal to 3. That means n value is 3, m value is 8. So if you are substituting here 2 power 3 into 8. Okay, that means 8 into 8. Okay, which gives 8 into 8. Right? So this can be alternatively represented as this 8-bit represent byte. Right? So we know the meaning for that term, byte. Okay, byte means it should have 8-bit. 8-bit can be represented as byte. So this 8 cross 8 can be represented as 8 byte. Okay. Clear? So the number of address lines and the number of input lines or output lines defines the capacity of the memory device. So here, if you are considering 3 address lines and 8 data input lines, then you can have a capacity of 8-byte memory. Okay. So control lines specify the direction of data transfer. So as you said, read, write. Read operation means we are taking the data from the memory unit. Okay, we are taking the data from the memory unit. The data is transferred from the data to outside world. Right? Writing means we are storing or we are sending the data to the memory unit from outside environment. Okay. So the control lines specifies the direction of data transfer. Right? So external environment to memory unit, that is write operation. Memory device to external environment. Okay, that is read operation. Okay, while writing the data, data is transferred into the memory. While doing read operation, data is transferred to the outside world. Right? And as seen in the block diagram, the M data input lines are used to store the information in the memory. Okay, the data input lines are represented as M. Okay, so that M defines the length of the input data. It may be 4-bit or 8-bit or 16-bit or 32-bit or 64-bit, whatever it may be. So if you are storing the information which is in 64-bit, okay, then M value is 64. Okay, if the input data is 64-bit, output data is also same in length. Okay, 64-bit. Output data is also 64-bit. Right? Here, input lines and output lines both are equal in length. Right? Then here, N represents the address lines. Okay, to point the particular address location. Okay, so based on the address line only, we will locate the memory cell inside the memory to read or to write the data. Okay. Then addition with these three lines, input, output, and address lines, we have 2 more control lines, which are helps to read and write operation. Okay, that helps to perform read and write operation. What is meant by reading? Right? So reading means we are taking the data from the memory or retrieving the data from the memory. Okay, so you can use this appropriate bit. A process of retrieving a data from memory is called as reading. Writing means storing the data. Okay, the process of storing the data into the memory device is called as writing. Right? Here also, the RAM can be classified as two different categories. Right? Static RAM, dynamic RAM. Okay, simply you can say SRAM and DRAM. Static
sir.
RAM, static random access memory. Sir, சொல்லுங்க sir.
ஸ்ட்ரென்த் 98 ரீச் ஆயிடுச்சு. சுமி மேம்கிட்ட மட்டும் சொல்லிடுங்க, அந்த லிங்க் மட்டும் சாட்ல போஸ்ட் பண்ண சொல்லிடலாம். ஸ்ட்ரென்த் 98 பக்கம் ரீச் ஆயிடுச்சு.
புரியலைங்க சார், என்ன சொல்றீங்க?
ஸ்ட்ரென்த் 98 பக்கம் ரீச் ஆயிடுச்சு. ஸோ சப்போஸ் தாண்டினுச்சுன்னா ஸ்டூடெண்ட்ஸ் உள்ள வர முடியாது இல்லையா, அந்த ரிமைனிங் ஸ்டூடெண்ட்ஸு.
ஓகே சார், ஓகே சார்.
ஸோ சுமி மேம்கிட்ட மட்டும் அந்த லிங்க் மட்டும் போஸ்ட் பண்ண சொல்லிடலாம்.
எஸ் சார்.
ஓகே ஓகே சிலோகுமார் சார், கண்டினியூ பண்ணுங்க.
ராம் சார் அந்த லிங்க் கிளாஸ் ரூம்ல போஸ்ட் பண்ணிருக்கீங்களா ராம் சார்?
எது மேம்? கிளாஸ் ரூம்ல லிங்க் இருக்கு இல்லீங்களா, செகண்ட் ட்ரிபிள் இடி அந்த லிங்க் தான் மேம். நான் போஸ்ட் பண்றேன்ல. ஓகே மேம்.
ஓகே சார், ஓகே சார்.
சார் யூ கண்டினியூ.
ஓகே சார், ஓகே சார். Okay, students. So RAM can be classified as static RAM and dynamic RAM. Okay, static random access memory and dynamic random access memory. So here is the flow chart of two categories of RAM memory. So what is the difference between these two kind of RAM memories? Okay, so static memory. So SRAM can be constructed with the help of latches or flip-flops. Okay, so we will see this latches and flip-flops in the third module. Okay, so here just take these words, latches and flip-flops. Okay, so latches or flip-flops is nothing but a storage element. Okay, so it can store 1-bit data. A flip-flop can store 1-bit data. It is a memory element. Right? So it is a kind of sequences circuit. So it will be discussed in third module. Okay. So the static RAM is constructed using latches or flip-flops. Okay. So here the latches or flip-flops is nothing but storage elements. Okay. Flip-flop can store 1-bit data. So with the help of 1-bit data, 1-bit memory element, you can construct the static memory, or you can say SRAM. Right? Whereas here, DRAM uses capacitors and transistors. Okay, so with the help of capacitors and transistors, you can store the information. So the storing elements are here, capacitors and transistors. Right? So static memory is a faster one because it uses flip-flops or latches. With the help of constructing SRAM, flip-flops and latches, it can perform a reading or writing operation faster. But in case of dynamic memory, it uses capacitors. So the capacitors little bit slow down the reading and writing operation. Okay, so the DRAM memory is slower, SRAM memory is faster. But here, the third point represents the main difference or advantage or disadvantage of DRAM and SRAM. Okay, so because of this utilization of flip-flops or latches, SRAM consumes more power. Okay, so flip-flops or latches consumes more power to perform read and write operations. Whereas in dynamic memory, it takes less power. Okay. So here we are using capacitors and transistors. So using these two elements as a storing element, it takes minimum amount of power consumption. Okay, it consumes less power. Right? Then again, the static RAM is a volatile Dynamic RAM is also volatile memory. So both are volatile memory. What is volatile memory? So it can store the data when it is powered on. Okay, if the power is cut off, then both the memory can lose the data. Right? So here in this comparison, you can understand the advantage and disadvantage between SRAM and DRAMs. Okay. So you can mainly see the difference here. SRAM is faster, but it consumes more power. Okay, dynamic memory is slower, that is, speed is low, but it consumes less power. Okay, and also the capacitors and transistors takes less amount of area. Okay, the space required for implementing these capacitors, capacitor takes more amount of area. Okay, once again, these are all semiconductor devices. Okay, we will fabricate these memory devices in the silicon chip. Okay, so silicon chip having lot of elements. Okay, you can fabricate transistors, resistors, capacitors. Okay, but capacitors takes larger amount of area compared to transistors. Okay, so because of capacitors involved in construction of dynamic RAM, it takes more space. Okay, so it takes more space but slower. Even though it is slower, it takes less amount of power. Whereas in static RAM, SRAM, it is faster one, and also it takes less amount of area in the silicon chip. Okay, because you can implement flip-flops latches in terms of only transistors. Okay, but it consumes more power. So based on the requirement, you can select the SRAM and DRAM in the applications. Okay. Then the memory unit stores a binary information in group of bits. That the group of bits are called as words. Right? So we are saying that the data input, which is represented by M. Okay, the length of M can be denoted as word. Okay, the length of input line or length of or the bits available or number of bits in input data is nothing but word. It can be represented as word. Okay, so memory unit is specified by number of words it contains and number of bits in each word. Okay, so in that block diagram, we have represented 2 power n into m. 2 power n into m. Okay, so the memory unit can be represented by number of address line and number of data line. Right? So 2 power n. Then n represents number of address line. M represents input line. So based on the two data only, we are representing the size or capacity of the memory unit. Okay, so here the number of words and number of bits in each word is used for representing the size of memory unit. Here is the example. 2 kilobyte is expressed as 2048 into 8. Okay, so here this 8 represents input data line, that is M value. Okay, so 248, this represents address line, 2 power n. Okay, if 2 power n having 2048, 2048, then what is the value of n? What is the value of n here? So here we are giving example 2 kilobyte. The 2 kilobyte represent the capacity of the memory. So then that 2 kilobyte can be expressed as 2048 into 8. Okay, here 2048 represents 2 power n, 8 represent m, right? So 2 power n cross m. Okay, here the 8 represent number of input lines, 2048 represent number of address locations. Okay, so here 2 kilobyte having 2048 address locations. Okay, in each address locations we are having a data with 8-bit length. Okay, so in each address location we are having data with 8-bit length. Okay, so 2 kilobyte represent 2048 cross 8. Okay, 2048 address lines with 8-bit data length. Okay, then another example, 2 kilobit is expressed as 2048 cross 1. Okay, here byte represents number of bits in the input data. Okay, 2k represent number of address locations, right? That's why we are representing 2048 into 8. Similarly, in this example, 2k bit. Bit means a single bit. Okay, so the input data is single bit, that is 1. 2k represent number of address locations, 2048. Okay, so in this case, 2048 address locations are available. In each address location, we are having the data with 1 bit in length. Okay, so as I said, 2048 represents the number of address locations. 8 or this 1 represents the number of bits that can be stored in each location. Okay, is it clear? Is it clear? Any doubt in this? So how to represent the capacity of memory unit? So here we are taking two examples, 2 kilobyte and 2 kilobit. So 2 kilobyte, how we are representing that number? 2 kilobit, how we are representing this kind of number? Okay, so 2k represent what and byte represent what? Is there any doubt in this example? So to represent the capacity of the memory unit, we will consider number of locations available in the memory and the number of bits stored in each address locations. Okay, so based on these data only, we will represent the capacity of the memory unit. Okay, so we will move on. So capacity of the memory unit is usually expressed as the total number of bytes it can store. Okay, so in the previous slide only we have discussed these things, right? So number of bytes it can be stored is nothing but the size of or capacity of the memory. Always we will represent the size of the memory in terms of bytes. Okay, so two control lines which are helps to decide the direction of data lines. It is going to be read or write into the memory, right? So read input causes binary data to be transferred out of the memory. Okay, read means we are taking the data from the memory unit. Okay, binary data will be transferred to the outside world from the data. Okay, we are taking the memory, we are taking the data out of the memory. Okay, so as I said, process of retrieving the data is nothing but read operation, or read input results in process of taking the data from memory unit. Okay, write causes binary data to be transferred into the memory. Okay, so these things are already discussed in the previous slides. Okay, anyway, we are recalling with random access memory. Okay, so what we are doing with this kind of control lines in RAM memory. Okay, so write input causes binary data to be transferred into the memory. It is also writing operation. Okay, process of storing the piece of data to the memory device, right? So now we will discuss about the construction of binary cell, that is single bit storage cell. Okay, the binary storage cell is a basic building block of a memory unit. Okay, so this particular cell can store single bit data can be stored in this binary cell. Okay, which is represented as BC. Okay, so this cell contains gates and flip-flops. Okay, so this binary cell, binary storage cell, or simply you can say BC, can be constructed using gates and flip-flops. Okay, with multiple inputs. Right? So this is the block diagram representation and the detailed construction of binary cell. Okay, so this is the block diagram representation. Here we are having input line, output line, okay, then select line. So select line helps to enable the binary cell. Okay, while doing read and write operation, based on this select line only, we will do these kind of operations. Okay, then this line, read and write line, helps to do read or write operation with this binary cell. Right? So here the select line is nothing but address line. Okay, so the address line gives the single bit data to select binary cell. Right? So with this input line, we will give the input data that is to be stored in binary cell. Output data gives the information that is retrieved from the binary cell. Okay, so this read or write control line decides the type of operation, whether it is input data to be written into the data, or the data from the binary cell can be read from the output line. Okay, so to do this kind of operation, this cell should be enabled first. So to enable this binary cell first, we will select line. Okay, by enabling or by giving logic 1 in this select line, okay, we will enable this binary cell. After that, we will do either of the operation, read or write operation. Okay, so this is the detailed internal construction of this particular binary cell. Okay, this binary cell having number of logic gates and flip-flop. Here we are using SR flip-flop. Okay, it should be studied in third module. Okay, so here I'm just saying what is the function of this SR flip-flop. Okay, just I'm telling the truth table of this SR flip-flop. Okay, so we are having from this block diagram, we can observe that there are two input lines. Okay, S and R. These two are inputs to this flip-flop. Okay, actually it is a SR flip-flop. S represents one input, R represents another input. Okay, S and R, two inputs. Q and Q bar, these two are outputs. Okay, two inputs, two outputs. Anyway, here we are using one output, that is Q. Right? So this block is acting as a storing element, single bit storing element. This block, SR flip-flop, can store 1 bit data. Okay, so just I'm giving the truth table for this SR flip-flop, then only you can understand the operation of this binary cell. Okay, so here are two inputs, so obviously we know that 4 combinations, 0 0 0 1 1 0 1 1. Okay, so when you are giving 0 0 to this flip-flop, what will happen? The output will be does not change. Okay, there is no change in Q output when you are giving 0 0. That means the data previously stored inside the flip-flop can be taken at the Q output. Okay, so if you are giving 0 0 in these two input lines, S equal to 0, R equal to 0, then there is no change in Q output. Okay, so previously என்ன data இந்த flip flopல store ஆயிருக்கோ அந்த data வந்து Q output lineல available இருக்கும். Okay, that may be 0 or 1. Okay, previously data may be 0 or 1. That 0 or 1 can be available at the output line Q when we are giving 0 0 at the two input lines S and R. Okay, so NC. Okay, then when you are giving data input data 0 1 to the flip flop, what will happen? R having logic 1. Okay, actually S represent set. Okay, R represents reset. Okay, so this flip flop also called as set reset flip flop. Okay, so set reset, where we are doing this set operation or reset operation on this output line. Okay, set means we are fixing the logic 1 on this Q output. Okay, while setting the Q gets logic 1. Okay, reset means output Q gets logic 0. Right? So here we are giving two inputs 0 1. So for this input combination, Q will be reset because R having logic 1. So the Q will be reset. Reset means Q goes to logic 0. Okay, logic 0 will be available in Q output line when you are giving 0 1. That means S equal to 0, R equal to 1. Okay, whereas for this third combination, S equal to 1, R equal to 0, here S is 1. That means set operation. We are performing set operation with this. So now the Q output will be logic 1. So for this input combination, Q will be 1. Okay, so when you are giving 1 1, if both the inputs are S and R, both are logic 1, then it will be undetermined. Okay, it will be undetermined. Okay, so these three input functions are very helpful in memory device. Okay, so with this introduction to SR flip flop, we'll discuss about this binary cell. Right? So how to perform read and write operation of RAM, okay, with this particular binary cell. Okay, so there are two different operations, read and write operation, so that can be performed in this single bit binary cell. Okay, for example, I'm going to read the data from the memory. So first I'm going to perform read operation, right? Okay, so to perform read operation, what we have to do? We are going to read the data from the memory. We are going to read the data from the memory. So first we have to enable the memory cell. Okay, so we have to enable the memory unit which is accessed. Okay, so first the select line should be logic 1. Right? So here we are going to perform read operation. So to perform read operation, for example, I'm considering logic 1 for read operation, logic 0 for write operation. Okay, it is a single bit control line. So single bit control line having two possible combination. So I'm taking 1 for read operation, 0 for write operation. Okay, so you can also represent write bar because it is a complement signal or logic 0 signal. Okay, so 1 it's a normal form, so read. Okay, where write is represented as write bar. Okay, when you are giving logic 0 on this control line, then you can do write operation. Okay, so now I'm going to do read operation, so I'm selecting logic 1 in this control line. Right, so select this logic 1, control line is logic 1. Okay, so you can read the data from this memory cell, that is binary cell, and that will be available in output line. Okay, so for example, if data 1 is or logic 0 is stored in this binary cell, okay, so that logic 0 will be available in output line, okay, when you are reading the data. Okay, so while reading the data, there is no need for input data. Okay, there is no need for input data because we are not going to write any information into the memory. We are just reading the data from the memory. Okay, so there is no need for having input on this input line. Okay, so by enabling the select line 1 and by giving logic 1 in the control line, you can do read operation. Okay, so while doing read operation, you can take the data from this memory cell which is stored already. Okay, or it may be logic 1. Okay, if the data stored in this binary cell logic 1 means, then you can get logic 1 as the output, right? So how this can be done in this internal structure? Okay, so apply these control signals in this diagram. So select line is 1. Okay, control line is also 1. Okay, here we are applying logic 1, right? So logic 1 enables read operation, right? Then, so this 1 can be inverted as 0 here, right? Then select is 1, read is also 1. So for this NAND gate, sorry, AND gate, 2 inputs are logic 1. Okay, so it is a 3 input AND gate. Among these 3 input, 2 inputs are logic 1. Okay, so the output will be depends on the third input line Q. Okay, so the data available in Q, based on that the output will be generated, right? If it is 1, then you will get output as 1. If it is 0, then you will get output as logic 0. Is it right? Okay, so now come here. So here at the input of SR flip-flop, we are having 2 NAND gates, sorry, AND gates. Okay, so these 2 AND gates also 3 inputs. Okay, one input is from select line, another one input is from control line, third one is from input line. Okay, so this AND gate having 3 inputs. One is from select, another one is from control line, that is read write operation line, and third one is input line. Okay, so here this NOT gate produces logic 0. So this logic 0 is applied to these 2 AND gates. If any one of the input is logic 0 to the AND gate, then what is the output of these 2 AND gates? It produces logic 0. Okay, this NOT gate produces logic 0 because control line is set with logic 1. So this logic 0 is applied to these 2 AND gates. So one of the input to these 2 AND gate is 0. So definitely output gate produces logic 0, right? Irrespective of input. That means we are not allowing the input to this memory element, that is SR flip-flop. Okay, so we are making 0 0, right? So input may be logic 1 or logic 0. That should not be allowed to SR flip-flop. Okay, which are input is blocked by these 2 AND gates. Right? Is it clear? Right. Okay. So if the 2 inputs S and R both are 0 0, means what? What is the output of SR flip-flop? In the previous slide we have discussed. So if SR flip-flop input 0 0, then Q will be not changed, right? There is no change in output. Okay, so any data previous store that will be available to output line. Okay, so when you are giving 0 0 to this SR flip-flop, then Q will be available with previously stored data. Okay, so for example, the previously stored data may be like this. Here 0. Okay, so previously stored data is 0. Then what will happen? The Q will be 0. Okay, so for this AND gate, two inputs are set with logic 1. Okay, so the output is depends on the data available in the queue, right? So definitely the output is 0. Okay, this 0 is nothing but this data stored in this memory element, SR flip-flop. Okay, if it is logic 1, the previously stored data is logic 1, then logic 1 is available in this queue, that logic 1 is transferred to output line. Okay, now you can read the logic 1 as the output. Okay, so from this explanation you can understand that we are doing read operation from the binary cell. Okay, by setting logic 1 in the control line, read write control line, we are disabling the inputs, okay, to enter into memory element SR flip-flop. Okay, then by setting the logic 1 in the select line, we are selecting this particular binary cell to perform both the operation. Okay, so here we are doing read operation. So by setting logic 1 in the control line, that is read line, we are reading the data which is stored already in the SR flip-flop, right? Okay, then how to perform write operation? Is there any doubt in the read operation? Is there any doubt in this read operation? Is there any doubt?
No, sir.
Okay.
No,
okay,
no,
okay.
sir.
Okay, so now we will see how to write the data into the binary cell. Okay, so for that, first we have to select the binary cell. So select line should be logic 1. Then to perform write operation, here is the write bar. So we have to give logic 0 in the control line. Okay, now we are going to do write operation. So we need some information, right? So we have to give some input data, okay, 1 or 0, okay, which is to be stored in the binary cell, right? So select 1. So logic 1 in the select line enables the binary cell for the operation, and this 0 on this control line allows to write the input into the binary cell. Okay, so on this input line we are having the data. Okay, it may be 0 or 1, right? So now we are not caring about this output, okay, because we are going to store the data inside the memory. That means we are going to write the data inside the binary cell. Okay, so apply these control signal to this detailed circuit. Okay, so here S is 1, select line is 1, read write control signal is applied with logic 0. Okay, so now this read write select line gives logic 0, that is applied to this output AND gate. So here one of the input for this AND gate is logic 0, select line is 1. Okay, even though the select line is 1 here, one of the input for this AND gate is 0, so definitely output will be 0. Okay, output will be 0, right? So the Q output line la enna data irundhalum, that is not transferred to the output line, right? Okay, then this NOT gate produces logic 1. Okay, 0 is inverted as logic 1. This logic 1 is applied to these two input AND gates. Okay, so here 1, here also 1. Okay, then the select line, it is set with logic 1. So this line is also logic 1. Okay, for these two AND gates, two inputs are set with logic 1. Okay, then output will be depends on the third input line. Okay, so the input line enna data nama set pannirukmo, that will be transferred to output of these two AND gates. Okay, for example, I'm going to write the input logic 1. Okay, I'm going to write logic 1 inside the storing element. Okay, that is flip-flop. Okay, flip-flop can be denoted as FF, capital FF. Okay, so we are going to write logic 1 inside the memory element. Okay, so here two inputs of these two AND gates are set with 1 1. So the third input for this AND gate is logic 1, because this line is directly connected with input line. But for this AND gate, the input is inverted. Okay, so we are using one NOT gate here. So this NOT gate produces logic 0. Okay, so one of the input for this AND gate is 0. So definitely the output is 0. But this AND gate, okay, produces logic 1. Okay, so now the input for this SR flip-flop is 1 0. S is equal to 1, R is equal to 0. Okay, so if the value of S is equal to 1, that means set operation, right? Set operation means the output Q will be set to logic 1. Okay, so this flip-flop can have logic 1 on this Q. Okay, now it means that we are writing into the data. Okay, we are writing the logic 1 inside the SR flip-flop. Okay, is it clear? By setting the Q, we are writing into the SR flip-flop. Okay, so now here the output of this SR flip-flop will be logic 1. Anyway, this AND gate is disabled because one of the input is 0, output still 0. Okay, it means that SR flip-flop holds logic 1. Okay, we are written logic 1 into the SR flip-flop, that is single bit memory element. Is it clear? Then the another input, if I am writing logic 0, okay, if I am going to write the logic 0, so input is set applied with the logic 0. Now this NAND AND gate getting logic 0, this AND gate getting logic 1, because this 0 is inverted using this NOT gate converted into logic 1. Okay, so now this AND gate having 0 on the input line. So one of the input is 0. So definitely output of AND gate is 0. Then for the second input AND gate, 3 inputs are set with logic 1. So definitely output is logic 1. Okay, now the inputs available for this SR flip-flop is 0 1. S is equal to 0, R is equal to 1. Right? So R is equal to 1 means reset operation. Okay, so reset operation, reset the output Q. Okay, now the Q is available with logic 0. Okay, then the available data in this Q is nothing but logic 0. That means we are writing the logic 0 inside the memory element. Okay, so like that you can perform write operation. Right? So to perform write operation, select and should be enabled with logic 1. Read write control signal should be applied with logic 0. Okay, by setting these two conditions, then you can apply the data which is going to be written into the memory set. Okay, for both writing operation, okay, logic 1, logic 0, still the output is 0. Okay, we are not care about this signal, output signal, while writing the information into the memory. Okay, I hope you all understand the write operation also. Okay, is it clear? Both operation, read and write operations. So here is the conditions to perform read operation. So to perform a read operation, read write signal should be set with logic 1. Then select line should be also set with logic 1. Okay, so for that condition, S and R, both the inputs should be 0 0. Okay, so if S and R both are 0 0, then there is no change in the Q output line. So it will gives lastly stored data to the output line, right? So input data 0 or 1 does not change the output. Okay. So these are the conditions should be followed for read operation, which is already explained. Is there any doubt in the read operation? So here is the condition for write operation. So to write value 1, that is logic 1 into the memory cell, we have to keep read write signal as logic 0. Select line should be logic 1. So to write the input data, input should be set with logic 1 because we are going to write the value 1. So input data should be logic 1. Okay. So for this input data logic 1, SR inputs should be fixed with S is equal to 1 and R is equal to 0. Okay. For that condition, Q should be logic 1. Okay. So data 1 is written into the binary cell. Okay. Similarly, to write the value 0, same condition. Okay. But read write should be 0, select line should be 1. To write the value 0, input data should be logic 0. Then S inputs of flip-flop gets 0 and 1. So for that input conditions, Q will be reset to 0. So data 0 is written into the binary cell. Okay. So the output is 0 during the write operation. While doing write operation, the output is does not considered. So the output is fixed with logic 0. Okay. That is due to disabling of output AND gate. Okay. So read write control signal disables the output AND gate. So output AND gate is fixed with logic 0. Okay. So output is always 0 while performing write operation. Right. So any doubt? Any doubt in this read and write operations? Ram sir? No doubt, sir?
சொல்லுங்க சார் சொல்லுங்க.
So we can move further.
No doubt.
No doubts.
Okay, so next we will see the logical construction of 4x4 RAM. Okay, so still now we have discussed a single bit memory cell. Okay, so single bit data வை எப்படி நம்ம ஸ்டோர் பண்றது ரீட் பண்றது அப்படிங்கறத பார்த்தோம். ஓகேவா? So now here the 4x4 memory. Okay, the size is 4x4. Right? So here we are going to discuss about 4x4 RAM memory. So for that we will use some other logic circuits along with binary cells. Okay, binary cells are only store the information. Okay, so to perform read and write operations, it needs additional circuits. Okay, like decoders and logic, basic logic gates. Okay. So this is the internal construction of RAM, okay, of k words. Okay, k represents address line, number of address lines. Okay, so here k is nothing but 2 power n. Okay, then m bits per word. Okay, m bits means number of bits available in input data. Okay, so the size of the binary cells or number of binary cells, k into m. Right? So we need k into m binary cells and associated decoding circuits for selecting individual words. Okay, so you can construct 4x4 RAM memory with the help of binary cells, which are used for storing the binary informations. Along with this binary informations, we have to use decoding circuits as well as logic circuits. Okay, some basic gates. Okay. So here you can observe the number of address lines, read write control signal, memory enable, that is select line. Okay, then input data, output data lines. Okay, so this address line gives the address location from where we are going to read the data or from where we are going to write the data. Okay. 4 cross, we are considering 4 cross 4. The first 4 represents number of locations, or it gives the required address lines. Okay, 4 cross 4 means you can represent 2 power n cross m. Okay, so 2 power n value is 4 and m value is 4. Okay, so 2 power n, that is equal to 4 means it can be written as 2 power 2. Okay, into 4, right? So this 2 represent number of address lines. So n is equal to 2. So n is nothing but number of address lines. This 4 is nothing but number of bits available in input data. Okay, so 4-bit data. 4-bit data should be stored or retrieved from the memory. For that, we need two address lines. Okay, 4. This 4 represent number of locations. So to represent 4 number of locations, we need 2 address lines. Right? So here we are having 2 address lines, I0, I1. Okay. Then the 4 bits input data. This 4 represents input data length. So here is the input data length. Okay. 2 power 0, 1, 2, 3. Okay. So like that you can store 4-bit data here. Okay. So to store 4-bit data, we are taking 4 binary cells in column. Okay, then this 4 represents 4 address locations. So here we are having 4 address locations. This is first address, second address, third and fourth. Or you can consider this matrix: number of rows, number of columns. Okay, number of rows, number of columns. So 4 number of rows, 4 number of columns. Right? This number of rows represent address locations, column represents bit length of the input data. Okay. So if I'm giving address line, here we are using 2 input address lines. So if I'm giving the data like this, I'm setting the address line as 0, 0. Okay, then what will happen? The 0, 0 gives, the 0, 0 enables 0th line of decoder. Okay, we have already studied this decoder circuit. Okay, so 2 cross 4 decoder circuit. Okay, so based on this address line, okay, so any one of the output line of this decoder will be enabled, right? So if I'm giving 0, 0, 0th output line is enabled. Okay, 2 cross 4 decoders, 0th line is enabled. Okay, so that means by giving 0, 0, I'm selecting the 0th address location. Okay, so this is my 0th address location, first, second and third. Okay, I'm selecting this address location. Right? Then we have fixed the address location. Okay, where we are going to read or write information. Then what we can do? After selecting the address line, we have to enable the binary cells. Okay, we have to enable the binary cells. Okay, so how to enable the binary cell? By applying read and write operation. Okay, so here this particular bottom line is nothing but read write control signal. Okay, then this one gives the input data, this gives the selection line for this binary cell, this particular line gives the output of this particular binary cell. Okay, so with the help of decoder we are enabling the binary cell. Okay, by enabling 0th output of decoder we are enabling the 4 binary cells available in the 0th row. Okay, binary cells available in the 0th row, these 4 binary cells are enabled. Okay, after enabling these 4 binary cells you can apply control signal, read write control signal. Okay, if you are giving logic 1, then you can read the data from this binary cells. Okay, then you can get the data from 4 binary cells. Okay, then there will be a output signal. Okay, from this 4 gates you will get the output data which is taken from these 4 binary cells. Okay, if you are giving logic 0 on this, then what will happen? What is the data available in the input data that is stored inside the binary cells? Okay, these 4 binary cells are written with the data available in input line. So here we will give input line, input data. Okay, so we'll give these 4-bit data using these 4 lines. Okay, so like that you can select appropriate location. If I want to read or write the data from the 3rd row, okay, 3rd address location, so I need to give logic 1 1. So if I'm giving address line as 1 1, then 3rd output of decoder is enabled, then these 4 binary cells are enabled to perform read and write operation. Okay, so by giving the logic 1 or logic 0 on the control line, either you can perform read operation or write operation on this 4x4 memory. Okay, so like that you can perform read and write operation on this 4x4 memory cell. Okay, then we will move on to read only memory.
Look, what
ROM.
almost 11.
Oh.
Time is almost 11. I have put one question in chat.
Okay, sir.
Sir.
How many address lines, select lines, data lines, input and output lines, control signal RW and size of decoder to build a memory device of a 1K byte memory? Students, can you understand this question? Sir asking how many address lines? Okay, sir. Okay, sir. So we need to construct 1 kilobyte memory. We need to construct 1 kilobyte memory. So for that, how many address lines, data lines, control signal are required? And the size of decoder to build a memory device of 1 kilobyte. Okay. So take it as this question as homework. So try to find the answer for this question while coming to next session. Okay. So to construct a 1 kilobyte memory, how many address lines, data lines, control signals are required? So shall we close the session?
Yes, sir. Yes, sir. Time is 11:01. We can close the session, sir.
Okay, sir. Okay, sir. Okay, sir. Students, if you have any doubts, stay in the meeting and ask your doubts. Otherwise, you can leave the session.
Sir, are 1024 address lines correct, sir?
No, Sabri. You read the question carefully. Okay. I have mentioned address line.
Okay, sir. I'm sorry, sir.
Selecting two memory, then you can have
See, sir also represented the size of the memory 2 power 10 cross 8 bit. From that also you can take the
directly
information.
tell the answer.
Ah, yes.